Aluminium is the most abundant metal on Earth. However, it is expensive because a lot of electricity is used to extract it. Aluminium conducts heat and electricity well, has a low density and does not corrode. This makes it very useful for aeroplanes, drinks cans, electricity cables and cooking pans. The aluminium ore is called bauxite. Bauxite is purified to yield aluminium oxide, which is a white powder. Aluminium is then extracted from the aluminium oxide. The aluminium is extracted by electrolysis. In this video, we are going to look at how aluminium is extracted using electrolysis. In electrolysis, ions need to pass through the electrolyte, and so the aluminium oxide must be made molten so that this can happen. Aluminium oxide has a very high melting point, over 2000 degrees Celsius. So instead of trying to melt it, the aluminium oxide is dissolved in molten cryolite. Cryolite is an aluminium compound with a much lower melting point than aluminium oxide, and so using this reduces some of the costs in extracting aluminium. The steel case is coated with graphite, providing the negative cathode. The positive anodes are immersed in the molten cryolite and are also made of graphite. Remember that graphite is a form of carbon. When the battery is turned on and electricity flows, the aluminium from the aluminium oxide in the cryolite forms at the negative cathode and sinks to the bottom of the tank. Here, it can then be tapped off as a pure liquid metal. The aluminium sinks because it is more dense than the aluminium cryolite solution. The oxygen from the aluminium oxide in the cryolite forms at the positive anodes. The oxygen reacts with the carbon of the graphite, forming carbon dioxide. The positive anode therefore burns away and needs replacing regularly. This is another reason for the extraction of the aluminium being so expensive. The overall reaction is aluminium oxide to aluminium plus oxygen. Let's have a quick look at the reactions at the electrodes. At the negative cathode, where the aluminium forms, the aluminium ions from the molten aluminium oxide cryolite solution are reduced. This means they gain electrons. At the positive anode, where the oxygen reacts with carbon to make carbon dioxide, the oxygen ions are oxidized. This means they lose electrons. So from this video, you should know that to extract aluminium, electrolysis is used. Aluminium oxide needs to be molten for the ions to move through it, and so is dissolved in cryolite to lower the melting point. The anode is gradually worn away because the oxygen from the solution reacts with the carbon of the graphite anode, producing carbon dioxide, and so the anode wears away and needs to be replaced regularly. Aluminium extraction is very expensive because a lot of electricity is needed.